So, good morning, participants. So, I welcome you all for the second session of day 4. Today we have Dr. R.Vimal SamSingh from SSN College of Engineering. He is associate professor in the Department of Mechanical Engineering. So, the professor going to handle the session on tools and techniques for data modeling in research. So now I'll request Mr. Ramos David to introduce our chief guest to the participants.
Good morning, everyone. I'm honored to introduce my mentor and guide to all of you. Dr. Vimal SamSingh R is an ardent lover of technology and stays up to date with the latest trends in the field of machine vision, artificial intelligence, sensors, and gadgets. He completed his undergraduate in mechanical engineering and master's in manufacturing systems and management from Anna University and secured University Gold Medal. He has completed his PhD from Anna University in the area of non-destructive testing, where he worked on developing new methodologies or framework in non-destructive testing, resulting in outcome of many patents and publications. He has also worked as a software engineer at Cognizant Technology Solutions for more than 3 years and has a total experience of more than 12 years in teaching and IT combined. He has published more than 25 international journals in the field of non-destructive testing, composites, electromagnetic product design, and sensors, stealth engineering in various reputed journals, to name a few. His paper on transit time dependent condition monitoring of PCBs during testing for diagnostics in electronic industry in IEEE transactions on industrial electronics with an impact factor of 7.503 is an outstanding achievement. He is currently guiding 7 research scholars who are experimenting on various domains of engineering and medical sciences, focusing and augmenting technology for industry. I'm very proud to say that I'm one among them. He has undertaken a funded project for the SSN Trust worth rupees 4.20 lakhs under the title Development of PVDF Embedded Composite Materials for Use in Stealth Application, and has been a co-principal investigator in a DST funded project of worth 30 lakhs. He has an outcome of research and he has filed 8 patents and 1 has been granted. He takes care of the Department Association, Industry Institute Partnership Cell, and coordinates the National Service Scheme. His professional recognitions include he's a member of ASME, he is a certified Six Sigma Green Belt professional, and ISTQB certified IT professional. Winner of Indian Testing Lead 2013, which is a prestigious national level competition for software professionals. He is very passionate about automobiles and follows Formula One and MotoGP race events. We are very proud to have you, sir.
Thank you, Amos. Thank you for the introduction. So, a very good afternoon to all the participants who have come here to participate in this FDP. I appreciate your effort, like during this time, to your commitment to learn something more to the field of education. So, really appreciate all of your interest. So, in today's session, we'll be discussing about the tools and techniques for data modeling and research. So, let me tell you a brief overview of what we will be seeing. Okay, so I will be giving you some brief overview. Many of us are inclined to research, and today research is also taking a new direction where people wanted more of our activities to be in line with industrial work. So I will try to bring about certain tools. So I will talk about what is data analysis, what are the visualization tools available, and how significant is data analysis in the field. Okay, and then we will be talking about the data modeling process, how the entire process. So it's actually a data modeling process is actually a structure. Okay, so most of us, if having a background of mechanical engineering, in the data modeling process, we generate data from experiments from other background, they did data by default. Okay, so data modeling process. So we what are the subsequent steps that we follow in data modeling? And then today I'll be talking more about ANOVA and regression, and then like giving you some simple case studies. Okay, I will not be in a position to talk in detail about the case studies, but I'll be giving you, some simple case studies like how these tools would make your research uh, look better. And then like industrial case studies, these learning these tools, how can we implement in industries because of which we could have some outcome. And today we were talking about there are many tools, so that title suggests tools, so I thought of like giving an experience on one of the tool, so which is called Google Colab, okay, which is a research tool that is used for modeling, uh, modeling data. Okay, so today I will give you a simple overview of the Google Colab tool, how to use the Google Colab tool, and like how to do a regression model basically with Google Colab. So that is something like we will be exploring today. Okay, so I will be what to say, like giving you an experience of how to use this tool. And then we will see, like if time permits, that's why, like the last two things, if time permits, we will see like how to use Minitab and AI for modeling. Today Minitab, almost if you take any research paper, the component of Minitab is always significant. Okay, so that is very important. So there is a such framework. Okay, the reason why today I will be talking more about ANOVA and regression is because today that has become a minimum requirement in almost all the journals. When you publish paper or any work, some statistical framework is actually uh, demanded in the market. So whenever when you write a paper, so that is why ANOVA and regression. Okay, and Minitab, now most of us are using Minitab to do this analysis. Okay, so Google Colab is also another software. Minitab is a proprietary software. Google Colab is an open source. So Google Colab would be a new field, new happening. Okay, people who do data analysis with Google Colab, they claim themselves as a machine learning engineer. It's not more of very new to the particular people who are working in Minitab or like SPSS. So that is something we'll see. And AI for modeling, there are two fundamental frameworks. So data modeling now has evolved a lot. Okay, like nowadays we work on AI model. The reason why we go for artificial intelligence is we see some intelligent creatures around us, and accordingly we try to model the data. Now there is something called particle swarm optimization. There is something called ant colony optimization. So in these things, we look at how the bird behaves, how the swarm bird behaves to its food. That is something we try to model towards the objective. Similarly, if you take at ant colony optimization, how the ant navigates itself to the food, it always tries to find the shortest route to the food. So that is what like ant colony optimization is being modeled about. So if time permits, I will just brief you only about fuzzy model there, on how to use there for modeling ant colony optimization and all those things, something like you should be aware of. So when you go for advanced modeling process, okay, when you go for advanced data modeling process, people look at these kind of tools. Okay, so today whatever you're going to see is only the basics, so basic tools that is actually required for data analysis, or a basic tool that can be required for formulating a problem and creating a solution. So that is what we will be discussing in today's session. Hope this actually enlightens you. Okay. So problem definition. So in a research work, most of us we require a problem definition. Okay, many of us know the framework of research, but the problem is many a time we stick with the same model, same problems. Okay, so that is what it's where the first objective of any research is to look for a problem definition which will actually add value to the society. Many people like when they work on many materials and those things, they try with lot of a lot of hard work, they come with a scheme, they do experiments, they try to, but the problem is how relevant is that particular work, how novel is that particular work, is something like we lead to formula. So many a time people say, like if it is the material that has been done already, I don't need to do the material. It's not like that. You could work on the material, okay, by means of collecting more data about the material and means of giving new analysis, you will be in a position to add value to the scientific community. So always look for opportunities to add value to the scientific community when you write papers. Okay, so new results is something like people are looking at. So establishing the need for solution is very, very important. Okay, so when you define a problem statement, you should see like how is it associated with the current progress. For instance, now today we're talking more about industry 4.0. There is a large amount of evolution happening around us in the industrial sector. So our research problem definition also, we should see like it is actually aligning. So we have to understand, what is the gap that we need to address, what is the drawback in the existing system, and what is the platform or framework today available in the market that can be incorporated into it to give us to give a new value to the society. So the very important thing is establishing the need for the solution. So that is where, we spend a lot of time on literature review. When you do the literature review, it is very important that you also try to understand the platforms that is being, developing around you in the particular area. That is one important thing. Justifying the need, that is also very, very important. Okay, so when I say justifying the need, again there comes the data. When I work on a problem, okay, I first have to establish that there is a problem. So nowadays, when you read a paper today, many of the review comments started coming in such a way, they ask you, to compare your research with that of the earlier publications in this particular area. The reason is because you need to establish factors like what you are developing, the sensor that is coming up, or the product that is coming up, how it is improved with respect to the previous generation. For that is very, very important. So this is something a paper outcome looks at. So which means when you start the work in a problem definition process itself, we should be in a position to justify the need and then conceptualize the problem. Okay, now this is where is very important. Okay, so this is where the key analysis comes in. Okay, so conceptualize the problem is how are you going to devise the solution. So when you conceptualize the problem, you should also see the feasibility aspect. Okay, so many a time we cannot be very ambitious. We should also see like what is the amount of infrastructure we have around us. So when conceptualize a problem, we should ensure that we are aware of the infrastructure. Okay, to be very practical, and then try to see like how are you going to frame step by step towards the objective. Okay, so that is how your problem definition should be there. And finally, when you go for the problem statement, you should be in a position to evaluate the target areas. Okay, so the thing is like you should know like what are the parameters that you are looking at if you're working on a particular material. Okay, and if you are going to change some of the you're going to have some fillers, or you're going to do some modification in the machining process, or you're going to bring in a coolant, you have to understand that what parameter it will have an impact, what is that I need to measure, the factor that I am measuring. Okay, what are all the parameters will have an impact on the factor that I am measuring. All those things is very, very important, you have to understand. So the very key important in your problem definition is you should be in a position to understand the parameters. Okay, what are all the what is that you're going to measure, and what are the factors that will have an impact on this measure. Okay, so this is something you should be in a position to do at an early stage. When you start doing this in an early stage, when you pursue the research, it will be very easy for you to construct a paper, as well as look for right data at the right places. So this is very, very important. Now this is a framework I told you with respect to research area, right? The research area doesn't restrict always to in-house research. Okay, when I say in-house research, we focus more on material research and all those things. There are also research where we could extend it to industrial segments. Okay, industry always generates huge amount of data. Okay, so people working in the domains of industrial engineering, okay, people working in the field of management, I've got a huge opportunity there because the data is already available. The problem with the engineering communities, many times they have to generate the data, whereas people working in the other domain, okay, the key aspect is the data is always available. Okay, so you have to collect huge volume of data, and you to ensure that you collect right data. Yes, that is very, very important in the field of engineer management. That is very, very critical in writing a paper. So even industrial solutions can be offered by means of using data analysis framework tools. So data in problem solving, how crucial data is in problem solving. Okay, so this is something, a small thing that I took from the net yesterday when I was preparing for the presentation. So I was able to understand that this is a very simple thing. Okay, where a small company that is actually performing like direct mailing process. Okay, so they take the habit of giving discounts. Okay, now they are looking at certain aspects. Okay, so the data is able to give a lot of inference. If you look at this, the bar graph that is here. Okay, so the bar graph is actually being pictured. This bar graph is actually generated from the data. Okay, so it is most of the data, like I give flyers and promotional in a direct mails about discounts, and I see how my business converts. Okay, so this is what they are actually tracking, and like this data is only converted to a graph. Okay, and from these graphs, this is what the scenario is. I'm able to create hypothesis. What is hypothesis? Hypothesis is, any research will have an hypothesis. That is, we call it as null hypothesis and alternate hypothesis. Hypothesis is nothing but something that we try to prove. Okay, so and the null alternate hypothesis is nothing but the opposite to that. Okay, so according to the problem statement that you are dealing with, what you are trying to prove will become one hypothesis, and if you reject that, the other will become true. So it is always important to establish the hypothesis. Hypothesis is nothing but the problem statement in which what you are trying to prove. Okay, that is very important. So here you could see the scatter plot. You will be in a position to understand that, like with more amount of discounts, with more amount of discounts being offered, okay, with respect to female candidates, we see like there's a huge turnout. So when I do a mailing process, when I do mailing, direct mailing to female participants, female prospects, with discounts, I see a turnout in business. So it helps actually business. A simple scatter plot helps me to give some direction on which I need to invest money. So data in problem solving is very, very important. So data is the fundamental. So if you have a data, this is nothing but an Excel sheet. If you have a data, for this data, we will be in a position to bring in a visualization tool. From the visualization tool, we will be in a position to generate hypothesis, and we could evaluate the hypothesis by means of using simple visualization tools. Okay, this is a very primary form of application of data. So significance of data. Now you see here there is a question. Okay, now if you look at it, there is a survey. Okay, so there is 1,500 residents. Okay, so the question is, in a survey of random sample of 1,500 residents aged 25 years or older from a particular county, 399 residents had a degree of higher. If the entire county has 635,000 residents aged 25 years or older, approximately how many county residents could be expected to have a bachelor degree? Now, this is a simple question, okay? But this question, is actually operating based on data. This data actually plays a major role. So here, what I'm trying to see, I take the ratio. So I see 1,500 residents. When there is 1,500 residents, 399 people get a bachelor degree. Now, the question is, what happens with 635,000 people? Okay. So what I do is I take the ratio. Okay, I take like 399 by 1,500. Okay, and then I multiply that with this particular set of people. I take this ratio and multiply with this set of people. Okay, and I look for the answer. So here, what we are trying to establish is the significance of data. Okay, so if you see, like, it's a very simple statement. The simple statement, we are able to build inferences only by means of using the data points. Now, how this data point is accurate, that's the next important question to be addressed. But at least it helps us to, because many a time when we work on data, right, many people say like it is more important is intuition. Don't work more on data, it might not be real. It is not the case. Data helps us to take a step forward in a very constructive manner. Okay, at least we move forward, at least we have a target in mind. So for that is why data is very, very important. So in this question, if you look at it, it's going to be 399 by 1,500. Okay, and 6,355, so like 400 by 1,500, so it's 4 by 15 into 6 lakh 35, you get somewhere around 16,000, 1 lakh 69,000 residents are the people who will be having the degree. So this is the answer. So out of these various possibilities, I'm able to come down to this is majorly because of the data point in this. So data is always helps you to go towards a goal. That is very, very important. That's why today, if you look at many publications, okay, if you start write a paper, and if you upload the paper, nowadays the research has evolved in such a way, like they are asking you to upload the data separately. Today there are platforms available where your research data has to be uploaded separately. You have to generate a DOI number, and this DOI number should be tagged with your research paper. Okay, and then you have to upload it. So this is the new evolution, that is a new form as that's actually evolved, where your data needs to be given to the public domain. Okay, so this way it will be useful, so that with this particular data, when I read the paper, I could use that particular data and see like whether this particular process is done, and I can learn how this particular algorithm or model is being working. So today, that is how things have changed. Okay, so to that extent, data has become very crucial. Many journals have started incorporating Sage, and elsewhere have started incorporating it. Mostly soon all the journals will start getting this DYI of our data. So that is very a good step forward. in the research community. We talk about data. Okay, so this is the types of data which I actually, I offered. I got this particular slide from an NPTEL course called Introduction to Research. Like this was very good. A good way of classifying data. Okay, so if you look at data classification, there are different types of data classification. Okay, one simple classification is continuous and categorical. Okay, that is one common way we define data. What is continuous data? What is categorical data? Continuous data is most of the time, it will be a continuous number. Categorical data will have, some values to it. Yes, no, those kind of data are called as categories. So that's one way of classifying data. The other people say is ordinal data or nominal data. That is again another way of classifying data. But in the research community, okay, this way of classification was very crucial. One is deterministic and the other is stochastic. So we actually classify data into two types, deterministic and stochastic. So this is one important thing that you need to keep in mind. Okay, whenever people ask you what are the types of data, you should say like deterministic data and stochastic data. When you're talking about what deterministic data, what is deterministic? Deterministic is nothing but we will have a mathematical function associated with it. Okay, that is what we call as deterministic data. Okay, so the data generated is actually sticking to a mathematical framework. Okay, so that is what we call as deterministic. Now force is equal to mass into acceleration. Okay, it's a deterministic data. Okay, because the as you substitute m and e could completely measure force, so it is a deterministic data. To talk about stochastic data, okay, now many researchers we generally generate stochastic data. Okay, we don't work on the concepts of f is equal to ma nowadays. Okay, we work for to build an outcome like that. So for that, what we do is we do experiments and we collect data and we see like how the data pattern is, and then we try to come up with empirical formula. Okay, so that is we call a stochastic data where the observations doesn't follow a definite mathematical function. Okay, so that is what we call as stochastic data. Okay, some people say it is one immediately random. It is not random. Okay, they do also some degree of pattern. Today in data mining and other aspects, we always try to understand what pattern. That is what we try to capture. That is why data analysis or data engineering has become a big a field nowadays. But stochastic is more that it doesn't follow a mathematical framework initially, but we capture the data and we try to build a mathematical framework for the collected set of data. So if you ask me how to classify data, we generally go for a deterministic and stochastic. If you look at deterministic, if you look at any deterministic aspects, the thing is, this can be modeled using Simulink. There is a tool called MATLAB Simulink. Okay, MATLAB Simulink. We can use this MATLAB Simulink tools to generate deterministic data and do some model verification. For instance, the spring damper system can be modeled, in a MATLAB Simulink. It is more of a deterministic data because it follows a certain set of equation, and where we could play around with that particular equation in order to formulate our problem definition. Okay, so MATLAB Simulink today a lot of opportunities are available to work in that particular area as well. Data analysis. Okay, so we have spoken about data, deterministic data, stochastic data. Why do we need to data analysis? Okay, in deterministic data, okay, it is already following a mathematical function. I said there is a MATLAB Simulink. Okay, MATLAB Simulink is a tool where when I have a mathematics function, I could develop a model based on the mathematical function in MATLAB Simulink, and I could create various solutions. So that is what will happen in MATLAB Simulink. Okay. Now, if you look at data analysis, okay, data analysis is very crucial. Even in MATLAB Simulink or deterministic data, data analysis is very crucial. With respect to stochastic data, it is very, very crucial because the pattern itself is something like we are not aware. So the reason why I collect stochastic data itself is to analyze the data and try to bring in interpretations. Okay, so that is where in stochastic data analysis becomes very, very crucial. So data analysis is nothing but a process of extracting meaningful and relevant information from observations. Okay, so that is what we call as data analysis. Okay, so there are data analysis, there are two broad categories. People say generally qualitative data and quantitative data. Okay, if you look at one set of people, they work more in surveying method. Okay, they go for qualitative data analysis. Okay, when people go for qualitative data analysis, they have an intuition in mind. For this intuition, they build a framework of questions. They supply questionnaires to all the people, collect those data, do certain statistical assessment, and try to see whether their assumption or intuition is right or not. That is one kind of data analysis. Okay, where they generate data by means of sharing Google Forms, or like by interviewing. There are a lot of interviewing techniques available. That is called as qualitative data analysis. In quantitative data analysis, like what we do is we create experiments. We do experiments. We develop a new material. Okay, we wanted to improve the lubricant. We add some nanomaterials to it. I'm not sure how it is going to behave. I use the nanomaterials. Okay, and then when the machining, I measure the temperature. I collect the data out of the experiments and then do data analysis and do some interpretation. Okay, so generally the primary answer, okay, the research questions, okay, in generally the primary research question that we try to answer is the minimum data analysis is trend. If you look at almost any research paper, it will have a trend. What happens when I vary the proportion of the materials? What happens when I vary the process parameters? What happens during machining? I do the variation in speed of process. So I look for the trends and relationship among variables. So that is why data analysis is very, very crucial. Okay, so it helps us to develop an empirical formula, okay, for a stochastic data, where the mathematical function by default is already missing. There is no mathematical function for it. When there is no mathematical function for it, what I do is I do experiments, collect data, and I try to come up with a mathematical function. So I move this from stochastics to deterministic framework. So by means of building a regression model for a particular data set, okay, which is initially stochastic form, I move it to a deterministic form because I have a mathematical function now associated. This is what most of our research paper contributes, okay, to the scientific community. The purpose of data analysis, why do we do it? Parameter estimation is very crucial. Model development and prediction. So today, why do we use data analysis? And this parameter estimation, okay, we estimate some parameters, okay. So when I do my experiments, okay, for instance, many a time, okay, in our experiments, I'm going to measure this particular y, and I'm establishing this as a function of x1, x2, and x3. Three variables. You can also go to generally in the engineering field, we try to restrict to 3 or 4 variables because the complexity is difficult for us. But nowadays, with the lot of analysis tools available, you could increase the x. So this is what we try to do. So here, this particular parameter is something like I try to estimate. So I try to develop an empirical formula for this particular parameter. So this is what we try to do. Then next we work on more on model development. Model development is nothing but the relationship, how this y and this x are associated with each other. Okay, so this type of assessment is something like we do with parameter estimation and model development. Okay, all those things, we try to build in relationship between x and y. And the tools like like artificial fuzzy logic, neural network, if you look at statistical tools like regressions, there are many types of regressions. We can use prediction, we can do prediction. So when I have a model in place, I will be in a position to predict. When I have a model in place, I will be in a position to predict. For this, if I have to prove that this association is correct. Okay, so here I am trying to associate that y as a function of x1, x2, and x3. If I am in my association, if I miss this, x is not actually having any influence on y, then there's no point in having this x as a function there. Okay, so that is very important. So when you start anything, you have to statistically prove that all these x, okay, all these variable as having a impact on y. We have to prove that, and then we go for model development. Okay, now feature extraction and classification today, with the developments, that's why I have to see like what is the happening around us today with OpenCV and Python, okay, and lot of data analysis tool available today. Feature extraction and classification become very, very significant. Okay, we try to understand how the data, from the data set, we'll try to identify a pattern. Okay, when I get a data set, I try to identify a pattern, and based on the pattern, I try to use some inference. People especially working in the field of NDT do a lot of work on these areas. Not only that, people who are working in the field of mission also work a lot in this. And then if you go to other fields, image processing, they do a lot of feature extraction and classification. Even in the field of management, in order to look for business opportunities, they usually use a lot of aspects of feature extraction and classification. Then finally we have hypothesis testing. Okay, hypothesis testing is nothing but verification of postulates, and then finally we go for fault detection. So for all these things, okay, fault detection is nothing but calculating, capturing signatures. When you use vibrations, okay, today vibrations is everywhere. Whenever a car, if we start a car, vibration is there. Okay. Now, by means of collecting these vibration signatures, can I bring in some inference? Okay. Now, there are a lot of research going on this area where we are working towards a solution. Okay. Especially in the field of NDT. Even in other areas too, people are working in this particular aspect. Okay. So, fault detection is again a very crucial aspect. Okay. So, feature extraction and classification also, if you look at in welding, is one area where people start using more of feature extraction classification, where we try to identify defects in weld, and we try to say like which defect is this based on the type of signature we are getting. The signature can be anything. It can be a microwave signature, it can be a electromagnetic signature, it can be acoustic signature. Get this signature, and then we do a data analysis and give some inference and classification, so that we make things easy at the user end. So if you look at the data analysis framework, okay, so today how it is we have sensors and process, okay, and this data is coming in. Okay, so first step if you see is visualization. Okay, so the first step of analysis is visualization. Okay, so what we do is, in this particular process I do integrity check. Okay, when the data comes in, when the data flows in, I visualize the data. For that we use lot of graphs. So that is why whenever you write a paper, you cannot see without graphs. More the graph comes in, it makes it easier for a reviewer to understand your work. Okay, because it gives good visualization, which means I will be in a position to do a good quality check. And for a researcher, it is very important for us to come up with these graphs, for us to understand that how good the data that we have generated is. Okay, and then we can do some form of pre-processing. Okay, so when the data comes in, straight away we cannot use it for model development or any other analysis. First we have to do a pre-processing of data, where we have to see whether the data collected has be validated. Then we go for knowledge. So here the first thing is integrity check. When you say integrity check, you actually evaluate the quality of the data, and then we go for analysis, where we go for knowledge extraction and validation. Okay, so here we go for descriptive analysis, conformity analysis, estimation, and modeling. Okay, so if you look at this, descriptive analysis is nothing but it is more of like I have a huge data set. From the data set I take it is more of a statistical analysis. Okay, so what we do is, when I get a data, it's a population. From the population I try to collect means, I try to bring some interpretation about means, or I try to understand what is median, mode, like a lot of factors, like a lot of parameters that can be obtained from a data set, that helps me to describe the observations, so that is very very important. Okay, and based on this we go for modeling and estimation. Okay, so applications generally where we use is monitoring, control, optimization, and innovation. Okay, so this particular site is also actually taken from one particular theme of NPTEL course named data analysis introduction to research. Okay, so there are 2-3 slides I take from that, because the slide was too good to explain this. So this is the data analysis process, and this slide contains almost all the key element. Okay, so it is very important to put the data in this particular framework. First go for integrity check, then go for knowledge extraction and validation, and then finally you apply to a particular field. So that is how it is very important. In order to do all these three, domain knowledge is very very important. In order to do all these three, domain knowledge is very very important. Okay, so this is the framework for do a data analysis or data modeling. We spoke about statistics, right? So there are generally different types of statistics available. Today we will talk about descriptive statistics, predictive statistics. Okay, there are a lot of different types of statistics that is coming up, but the most common type of statistics generally we use is descriptive statistics. Okay, so when we collect the data, from the data, okay, we try to build in observations, and this is the observation that I document in my research paper and I try to communicate across to other researchers. Then there is something called inferential statistics. So inferential statistics is nothing but we try to make some inferences. We try to make some, and the descriptive statistics is generally a direct answer. Inferential statistics is actually kind of an indirect answer, where I try to build some inferences out of the results. So that is what inferential statistics is all about. Then finally we have hypothesis. So hypothesis is nothing but it's a method we use to test a claim. Okay, when you talk about hypothesis testing, there are different types of hypothesis testing available: t-test, chi-square test, okay, f-test. So there are different types of tests available for hypothesis testing. Okay, depending upon the problem and depending upon the type of data we are handling, we need to go for particular type of hypothesis. So that is very particular type of testing of hypothesis. For instance, in the field of medical field, t-square test and chi-square test is very common. The reason is because they try to give different to two groups, they give same medicine and they see like how their performance affects the individual. Okay, so this is what we go do in hypothesis testing. All the research starts with one particular point of data collection. Okay, here what you see is database is what like today most software engineers does. Even nowadays mechanical engineers started moving to this area because we started putting in lot of sensors today onto the mechanical systems to collect data. So our domain knowledge also dependence on the sensor become very crucial nowadays. And other form of collecting data is interview and questionnaire. Okay, so this is what the management guys often try to do. They try to understand by means of interviewing and by means of questioning people, they collect inferences. Okay, and then like it's very difficult. We say like interviewing and questioning are a very easy thing. Okay, you really don't understand the degree of randomness that is actually associated with this kind of factors. It's very challenging. Okay, so when you capture the collected data, it is very important that how effectively I build in my question that actually results the success of their result. And like our like most of our engineering case, we do experiments. Okay, and we observe, record it, and then we do processing. So data collection can be done in these ways. Whenever you collect data, validation is very important. So stratification is on process that we do generally. Grouping up. Okay, so when I get a huge amount of data, I try to categorize them into different groups. Okay, that is what we call it as the process of stratification. Okay, so that from the large population we try to figure out and take the response with respect to particular condition. Okay, so here you see like in the medical field, okay, they are doing a patient stratification where like they're grouping of people and then segregating the results. So this is something we do especially when you go for AI modeling. We use this kind of analysis. Okay, now when we go for visualization, this is the kind of visualization that you see is the most basic form of visualization, and this kind of visualization is very important. You see, this is nothing but a bar graph. This helps me to understand the data much better. Okay, if I have it in form of table, if I have it in form of table and give values, okay, I will not be in a position to infer anything much from it. Okay, when I put it in form of a graph, it is very important that I will be in a position to add value to the person who is reading it or reviewing it. So that is why in research articles, when we come up with improvement, we try to come up with bar graph. So visualization is very important. Even you look at here a pie chart we have used. This gives a better visualization. Okay, of a particular, this helps the reader today. That is why even in the classrooms, okay, students have been asked to build up these kind of info. Data interpretation is one important study today. People have been demanded much. Okay, that is majorly reason is because they should be in a position to have a good understanding about the data that they are studying. So first thing very easily we could do is visualization. Okay, so that is why we call it integrity checks. I could see like how the data is coming out, then I could go for building model or something. So first thing is visualization. Okay, for that many things can be used. Bar charts and pie charts are very commonly used. So these are some of these charts that being used: bar charts, line charts, pie charts, bubble charts, stacks charts, scatter plots. It goes on and on. Okay, so today there are wonderful platforms available. Okay, like if you look about graphing or visualizing tools, like MATLAB is very crucial. Okay, 3D graphs can be very superly generated in MATLAB. You can also use tools like Origin. Origin software is almost like all the researchers we use generally for graphing applications. So whenever we come for graph, we don't use much of Excel. Okay, we generally do the graphs in Origin software. The quality of the output would be very nice. Okay, and then like bar chart, line chart, these type of charts are very commonly used. Okay, if you look at the if you look at this data, we will be in a position to very clearly inference. If you look at this is following a different pattern, this is following a different pattern. This kind of inferences can be very easily made. If you have a huge table, okay, with lot of values, this inference cannot be obtained easily. But when you visualize it, we will be in a position to obtain it easily. So it is very important for us to come up with visualization tools. So line graph generally we use when we have we use generally like x-axis as a quantity variable. Okay, and then it is having some impact. This is more of we call as trend graphs. Okay, we call it as trend graphs. So mostly trend graphs are very common in the field of engineering. You could see these trend graphs are abundant. Okay, because when we get the experimental results, the first thing what we do is we go to plot a trend graph and to see whether my result is in line with the physics already available. Okay, so that is something we try to associate. If there is a deviation in the physics, then we try to dig for the reason. So that's where the research actually begins. Then we go for bar graphs. So bar graph is when you say like when I have made some improvement, okay, compared to the existing state of art, I use bar graphs. I use bar graphs to compare my improvement in the existing state of art. So that is one common reason why we use scatter plot. Generally we use, when we have 3 4 variables. Okay, so how these variables are associated with each other, will be very easily understand by means of using scatter plot. Many a time the model validation. Okay, we build data model validation is done by means of using scatter plot, and then we have pie chart. Okay. So these are the common tools we use. Pie chart generally we use to indicate, like the reason why we select a material, the reason why we select the application. Okay, the reason why this sensor is being used. So to prove that, we use pie chart. So data science as a process. If you take data science as a process, if you look at it, we have raw data being collected, and this data has to be processed. Now this is where we start with exploratory data analysis. Okay, so the data is being processed. Okay, there are different types of data analysis. This is being called for different reasons. Okay, so this is a flowchart that being used, okay, in order to explain the process. Mostly most of the data modeling process follows this data science process. Raw data is collected, data is processed. What is meaning by data is processed? I try to understand the data, look for the data, look for some problems in the data, and then I clean the data set, and then I go for generating models and algorithms. Okay, and then I try to build some inference out of it. So this is the data science process. So first raw data is collected, data is processed. When data is processing, I clean the data set, and the clean data set is used for modeling, where I try to build in association between y and x. I build some inferences out of it, and then I build in some visualization report to project my effectiveness of the model. So typical values, okay. So if you collect a data set, okay, generally the typical values will be either continuous or categorical. Okay, so that will be often or any, even if you do experiments, or even if you are going to do a data collection process from questionnaires, the data will be either continuous or categorical. Okay, continuous data is more of numerical one. Categorical data like male, female, okay, all these are categorical data. Okay, so this kind of data will be available in my data set, and it's very important for us to understand this data. And if when I look at the data set, if all the data are categorical, okay, they cannot use the categorical data in my data modeling process. So I should be in a position to code them. Okay, so generally what we do is we code them and use it in data modeling process. Okay, so that it will be very easy for me to process it in my model. Now this is something called Anscombe data set, we call this. Okay, you look at this data. Okay, is there any inference that you could build? You just observe it. Is there any inference that you could build? Many of us would say yes, right? Many inference is something like we could build from this data set. We see like when I visualize this data, I come to a conclusion. It's an open source data that is available. Okay, so this data, if you visualize it, looks when I during visualization process, 4 data set looks very different. Okay, but if you statistically process this 4 data set, they have the same median, mean, and mode. Okay, which clearly indicates like they are almost same. Okay, but the fact is when you look at it, when you build in visualization, it is not the case. So that is why it is very important for us to do data analysis very seriously. Okay, because when you do visualize it, you look at, it's almost same, it's very different. Visualize it, it looks very different, but when you process it statistically, you see like all the 4 data sets are same. When you the values are obtained the same. So this is something, the carefulness that we need to have when we are working in data set. Misrepresentation of averages, this is also a major problem. Okay, when people use with data set. Okay, now I say like my team is having an average age of 25. Okay, that doesn't mean all of them in the team are at an average age of 25, right? Because only if my median is 25, all of them are at the age of 25. When I say average is 25, what means like this is how my team could be formulated for a competition. Though the average is 25, doesn't actually achieve the goal. So it is very important for us to look at the data set very, very carefully. The other thing that helps me to build more understanding about the data is the distribution. Okay, there are different forms of distribution today available. Okay, that helps me to understand the data. Now, if you see, the first one is called Bernoulli distribution, the other is binomial distribution, uniform distribution, normal distribution, Poisson distribution, exponential. These are very commonly used distributions. Okay, so when I bring in visualization, okay, so I don't bring in visualization just like that. When we bring in visualization, I should see that my visualization fits into any one of these distribution to have some significance. So it is very, very important for us to be aware of this distribution. To know what about this distribution, there are a lot of statistical courses available. You could use it, but it is very important when you do data analysis to understand the distribution. For us, most of the time, okay, in the field of engineering, okay, our data will always fall mostly into normal distribution, because most of the time the results that we're dealing with are linear. Okay, but if it's not linear, then it might not be a normal distribution, it may fall to some other distribution. So it's very important for us to understand the distribution of our data set. Then we have to do pre-processing of data. When I have the data, okay, we have to identify duplicate records. So that is why even when you do experiments, they don't allow you to write a paper with only one set of experiments. They ask you to do 2-3 runs of experiments, because sometimes, because of the repeatability or reproducibility issues, we might not have correct data. Okay, so duplicate reports might pop up. Okay, for us, when you do 27 or 35 experiments, it might not be the reason. But if you look at like other sensory data today, when we collect today sensor data, sensors actually generates huge amount of data. Okay, today with sensory data, I have huge amount of data being collected. So when huge amount of data is being collected, I have to look for duplicate records, and also I should look for what are the faulty data available, and I have to clean the faulty data. There might be one experiment alone will show a very different result. I cannot take that into doing my building my look at the distribution, or so any other visualization tool will help me to the distribution and visualization tool will help me to figure out it very clearly, and it will also help me to eliminate the outliers, which is nothing but suddenly one data one when everybody is going on one particular rate, then somebody is alone doing exceptionally well, then there is something wrong, and I cannot include them into my system. Okay, so I remove them from the system and use the other values only to do benchmarking for, or to bring to set targets. So eliminating outliers is very important. There will be some cases where some missing data, or whenever when you deal with data set, definitely that will be a problem. So you'll have to logically fill in the missing data. Okay, that is very, very important. And then adjusting data for fundamental conversion loss. Okay, there might be some mathematical framework available and the data generated might not stick to it. So you'll have to see what are the conversions available for us. For instance, if there is a data set that is not sticking to normal distribution and you wanted to process it only normal distribution, there are fundamental conversion laws, like the distribution like variable distribution can be used to convert the data. So this kind of distributions has to be used. So the fundamental conversion loss has to be considered. Missing value, how to fill the missing value. Okay, so hot deck is a process where we try to use a randomly similar record. That is one thing we use, or substituting with either mean or median depending upon the data how it shows. Sometimes very commonly we use replay with zero or constant value. Okay, sometimes we also use regression model and predict it, and then we try to use. Okay, so these are some objects we use to fill in the missing value. Generally for experiments, the only way to go about is redo the experiments. This when you get the sensory data or the means of other data processing, when you get huge amount of data set, is what the way of missing value is to be done this way. Look for outliers. Okay, so box plot is a very common plot nowadays being used. Almost most of the papers you could see box plot. Box plot will also help me to understand the outliers. Standard deviation curves will also help me to understand the outliers. Minitab is one software, very easily you could generate these two assessment and check. Directional relationships, I said 10 graphs, right? This 10 graphs helps us to give me the directional relationships. When I talk about positive covariance, negative covariance, weak covariance, what it indicates, like how my data is flowing. Okay, when I continuously improve my variables, how the response is changing. All those things can be inferred from these variances. This helps me to understand more about the data. So standard deviation and variance, like is one key aspects we generally use in order to understand the data more. When you have to give a closer look at the data, we go for estimating these parameters. Okay, so this is very, very important. Okay, so there are many ways or times if you look at it, using this concept is very, very important to have better interpretation of the results. Okay, so here like we have a situation where we are actually using the data sets, okay, and we are computing mean. So we use these three values and computed mean, okay, and we have computed variance with these, for the same values we computed variance, okay. If you look at these two, you see a big difference, right? There is difference, okay. So which is indicates like data pattern is varying with respect to the kind of parameter that you use for assessment, okay. So here mean is 394 and here the value is 147, okay. So you could see the variation in results between mean and standard deviation. They are not the same, they are different, and this helps me to get lot of interpretation. If you look at this, okay, now this is what the, when you have a larger standard deviation, okay, when I said that the average age, this can, when you have small standard deviation, it indicates like almost, when you have smaller standard deviation, it indicates like, so when I say like average of age 25, or like when I go for the standard deviation value, the spread is less, which clearly indicates like the values are very closely close, the answer would be correct. When I go for larger standard deviation, the spread is more, okay. So if you take a marks itself, okay, when you talk about my class average is 85, okay, here and here also, when you say your class average is 85, this is what you're talking about mean, it doesn't give correct result, okay, because the spread is different. In this class the standard deviation is very small, indicating like most of the students have scored very close to the goal. In this case the spread is so big, what happens is, it's not like all the students, I have set of students who do really very well, I have set of students who don't do really very well. So this is kind of, inference that we'll be able to understand with using standard deviation and mean, okay. So when you do with data, especially with respect to your problem domain, you need to look and bisect the data and understand, lot of things, okay. Many a times when you do one experiment and collect the data, with the data, by means of using deep data analysis, okay, you could write lot of research papers, okay. So once one good set of data you collect, by means of using various modeling tools, you could come up with variety of papers, okay. So or then, once the experiment is done and then you come to the drawing board, it's all with more like, how you use computer and system, it makes things easy for you, okay. Especially, people in the research world, it is not easy for us to continuously generate, do experiments and collect data, okay, because all the experiments are very expensive, okay. So if you're able to master in this particular area, okay, with one set of data could come with different research outcomes, okay. So this is correlation coefficient, okay. Correlation coefficient, as I said, it tells you like how the parameters are very closely associated, okay. Here you see these are the possible correlations available, okay. Zero is no correlation, okay. So these two parameters are no way associated with each other. If I change x, nothing will happen to y, okay, which means x and y are not associated with each other at all, okay. So these are all, low correlation, this is low positive correlation. And if you see like perfect negative correlation is also very good, perfect positive correlation is also very good. It helps me to give a trend in one direction. So it actually ranges from 1 to -1, okay. You could see this range of correlation coefficient. So here I have given you temperature and ice cream, okay. Later I think like this PPT is something like you will get, if you get, try to develop uh, do a regression, generate a correlation coefficient for the table given below and see how the inference comes about, okay. So generally this is the formula we use to calculate the regression coefficient. Whenever I build the model, okay, this correlation coefficient helps me to see like the experimental result is there. I have built a model, okay. It can be a model or it can be a regression model. How this result is closely associated with that of the experimental outcome, this can be very well told by correlation coefficient. Other parameters also, that mean square error we use, but many a times we go with correlation coefficient. And this is, if you look at many papers too, like like we have the correlation coefficient is being used to compare the experimental value and model value. For the previous problem which I showed you, okay, for this data set, okay, if you do, compute regression correlation using the formula, you will get the value as 0.95, okay. And this can also be represented in scatter plot, okay. So if you see, when you draw a scatter plot, these things will help you to have some trend and build some inference out of it, okay. This gives me good relationship between x and y. Next we go for analysis of variance, okay. So in analysis of variance, what I do is, when there's a single population, we don't go for ANOVA. When there is multiple population, in that case we go for ANOVA. ANOVA is very, very important, okay. It helps me to compare 3 or 4 different groups, okay. So we'll have to understand that in analysis of variance, we have population mean and grand mean, okay. So which means like each of this thing will have a mean, and there is also a common mean called grand mean, okay. This helps me to compare the means of different population. Okay, so whenever when there is a need to compare means of different population build inference, we go for analysis of variance. Okay, so here we are just example, giving an example. Only if you compare with apples, mean, median, and descriptive statistics will be much more. But if here we have different different article, different items, different populations. Okay, in that particular case, we need to have analysis of variance to understand the means. Okay, so it is very important. Okay, now in there was like one small area where this is very needed is showed here. There's a study where they are trying to see like how music is improving the performance of the student. Okay, so whether it is impacting in good way or bad way is the hypothesis that has been set, and they are working on it by means of using design of experiments. Okay, I am planning my experiment, so always we have DOE to plan my experiments. Okay, so I have classroom A, okay, with constant music, classroom B with variable music, and classroom C no music. I get the results. So this is how my experimental results are documented. Okay, we have three different mean and then we have grand mean. Okay, now if you go only by with this mean analysis without considering grand mean, only if you go with mean analysis, for us class A comes good, right? They become good player. Okay, but it might not be true, right? It may be because there will be a lot of various other factors could be an influence as well. Class A sample might have students who are really doing good, or it could be the kind of assessment that has been done, what is then taught for them in the class. So this kind of inference might not be very helpful. That is why we go for analysis of variance, where it helps us to address more questions. Okay, because here we see like yes, there is an impact. We cannot say whether the impact is good or bad very clearly. That is why we go for analysis of variance. Okay, so ANOVA generally what happens is like if you look at two sets, this is one set of data, this is a second set of data. If you look at this data as a whole, you look at all this data as a whole, you could see like they are very different, right? But look at the inference here, all are same. Okay, so this is very important. Looking only at the means, we can see that they are identical, but they are actually population of differences. So using the mean alone is not sufficient. Okay, so if you allow mean alone and go for building inference, we will not be in a position to talk more about the data. So we need to go for analysis of variance. So here we have two sets of data where we use box plots. So box plots also today become very familiar tool. Okay, by using box plots, we try to, here also the mean is almost same, but in the box plot it tells me a very different story of both the data. Okay, so this is why data visualization comes in handy for us to understand. So for this kind of things we use analysis of variance, where analysis of variance will help us to tell the group variability. Okay, so it is very important. Okay, so when samples overlap, okay, their individual mean won't differ by a great margin. So these are two samples. When they overlap by a slight degree, then the individual mean will not vary by a great margin. So in that case we need to go for techniques like ANOVA. Okay, now these kind of samples where there is complete distinction, that there is there is some extent where individual mean, okay, would be significant. Okay, so that is very important. So if you look at this, here overlap is there. Okay, here we don't have overlap. Okay, consider the given distributions. We have three samples and you look at the variability. Okay, and each of the distribution. So this population is a bigger population. Now consider the another distribution. Okay, there is less what you say distribution. Okay, although the mean of samples are very similar in the above image, okay, they seem to belong to different populations. Okay, so whenever in order to study group variability, we use analysis of variance. So what are some of the terminologies that we use in analysis of variances? We need to understand what is factor and what is level. Okay, so factor is nothing but a variable. Okay, factor is nothing but a variable. Okay, many of us use lot of variables in developing our experimental models. Level is like what level you are using this variable. For instance, I'm talking about speed of the car. Speed of the car is the variable. Okay, I try to operate them in different levels. One is low speed, okay, which is 0 to 50. Then I go for medium speed, which is 50 to 100. Then I go for high speed, which is 100 to 150. Okay, now when I group my parameters like this, okay, this parameter, okay, for instance, I take 25 here as low, I take 75 here as medium, and I take 125 here as I. Okay, so this kind of grouping, okay, is we call as levels. The whenever we have more number of levels in a particular factor, okay, you will get like very good inferences out of the result. But the problem is the data modeling associated with will become complicated. Okay, but whenever we go for ANOVA, okay, factor and level would be one of the key important aspect. Okay, so that is very very important. So factor is nothing but variables. So when I take y is equal to function of x1, x2, x3, x1, x1, these are all variables. X1, x2, x3 are variables. Y is nothing but the outcome. Okay, and these variables are called as factors. Okay, and the levels I consider each factor is called, and the ranges of levels that I consider is called levels. Okay, so every factor will have different levels during my DOE modeling. Okay, so and single factor ANOVA will be used when we have one y and one x. Okay, and then two factor ANOVA is there when we have more number of parameters to be assessed, when there are more number of variables. There are different types of ANOVA available, like like one way ANOVA, two way ANOVA, three way ANOVA, and multivariate ANOVA is available, which helps us to give a lot of statistical inference. The other format tool that we are using is regression. Okay, regression like helps us to uh, when I say y, okay, as a function of x and x, okay, this helps me to build in a relationship. Okay, so if you took a linear regression, okay, this is a simple linear regression. When that my trend line, when my trend of the response is like this, many of the engineering applications might fall in this category. Okay, especially when you work on materials, and that particular domain might fall mostly on linear regression or multiple regression, depending upon the number of variables you consider. Okay, the value sometimes might become quadratic or cubic. Okay, the regression is quadratic regression is also available, and then cubic polynomial, quadratic polynomial and cubic polynomial can also be used to build models when the data is not linear. Whenever the data follows random patterns, then we could use cubic polynomial, quadratic polynomial, and cubic polynomial to establish relationship between y and x. This is generally used in time series analysis, where we use for forecasting. Even in engineering experiments, we based on the trend graphs, we could make analysis. Only based on the visualization, whenever your data set follows normal distribution, this kind of visualization can be brought in. Okay, so that is very very important. So most of the time, in order to perform linear multiple regression, your data set should be undergo what do you say, normal probability test should be passed. Okay, your data set only if it's sticking onto normal distribution, then you will be in a position to do linear regression or multiple regression. Many of us don't do those kind of validation, but it's very important to do those kind of validations to be very accurate about the result. Okay, so having spoken about something, like I'll just tell you like how we can use this in some of the engineering experiments. Okay, so this is one simple engineering experiment where we're taking like three parameters: spindle speed, feed rate, and drill diameter. Okay, now these are all nothing but I'm just giving a brief overview because I'm running out of time here. So I want to teach you some aspects of Google Colab. So I'll run in quite fast here. Okay, so the spindle speed, feed rate, and drill diameter, these are all variables. Okay, and these are all levels. This is levels. This is variables, which is nothing but factors that is being considered. Now, for instance, if thrust force is the response I'm capturing. Okay, now I'm establishing the thrust force is nothing but my y. I'm establishing it as a function of spindle speed, feed rate, and drill diameter. Okay, this is what my modeling is all about. Okay, so from my literature review, when I define my problem statement, my literature review should give me indication like spindle speed, feed rate, and drill diameter or something will have an impact on thrust force. So there should be physics association between this for me. Okay, now I will go based on this I am planning out experiments. Okay, so I'm also taking three levels. Okay, since we are going to do experiments, we are strictly reduced to three levels. When you go for bigger levels, the data set required would be higher, which will involve in cost of experiments. So people working in engineering field, I always request them to go with lesser levels. That will be helpful for you. But in scenarios where you are going to generate the data set directly from the company, in that particular case you are free to go with more number of factors and more number of levels and increase the complexity data analysis. That will help us to get some good publications. So here I'm modeling the experiment based on DOE method. So there you saw like, right, the teacher developed design of experiments based for a music. They created 3 scenarios. Similarly, okay, for this parametric combination, okay, we call something called orthogonal array. 27 combinations are possible. Okay, so what is orthogonal array? What is this? No, we could have one different session to understand. I'm just telling you how we are building the experiments. Okay, so based on these parameters, we are considering this design of experiments pattern, okay, to be considered for our experimentation, and we map those values to this table, and then we build the experimental plan. Okay, so after we building this experimental plan, okay, so based on this L27 orthogonal array, based on these parameters, based on these variables, based on these variables, based on the levels, you could see levels, I have brought in almost all the permutation of combinations into this experimental set. Okay, and then I'm calculating my response. Now the data which I'm having is stochastic data. Okay, it is not deterministic data, it is a stochastic data. When I say stochastic data, there is a degree of I cannot say randomness. I don't have a model connecting these two. This is not deterministic data, this is a stochastic data. Okay, I have generated. Okay, now the data visualization. Okay, by means of simple line graphs, I could build some interpretations. I could build some interpretations. To some extent, I could say like the data is linear, because when I progress, I could see it's very linear. So this kind of data visualization will help me to understand. Now I need to address it by physics, by means of physics. I need to look into the physics, why the variation is happening like this, and I need to explain this in my research papers. That's very, very important. Now I use ANOVA technique to bring in some more factor. If you look at this, this is very, very critical. Okay, I try to bring it in association such a way like this is the amount of percentage of contribution that is drill diameter is having on torque or thrust force. Okay, so I have put a torque. Okay, if you know, so when I use drill diameter, my ANOVA, my statistical framework says like 76% ANOVA is having an influence on the outcome, and only 6% spindle speed is having an impact on the outcome. So this is very important. Now I know like what to tune, what to fine tune is something like I'm pretty aware of. So this is very, very important. This kind of assessment is what ANOVA helps us to give. In additionally, it also tells like whether if you look at this, this is called as F test. Okay, if you look at this, these parameters indicate like all the values are having a significant impact on torque. So all the parameters that I have considered for my modeling is correct. All of them are having influence. If any of this F value is less than, okay, if any of the F values less than a particular parameter that is based, we also estimate a F value based on degrees of freedom. If that is less than this, then that particular parameter is something like we will eliminate. For instance, if the value of feed rate comes less than the F value, okay, then we will eliminate this parameter. Okay, this parameter does not have any of my influence on my output. So these are the parameters that is considered, and this is having an output onto my response. Okay, so this kind of analysis can be made by means of using ANOVA. And for this particular data set, we have developed a regression model. Okay, now what is that we have done is, from a stochastic framework we have brought this to a deterministic framework. Okay, going forward this is deterministic. Okay, so this is the contribution for us to their particular research paper. Okay, now we are coming up with a deterministic. So going forward, people working in this area need not generate stochastic data. They could use my formula or use our formula and then generate data in a deterministic manner, which makes things easy for them. Very easily they could put these particular parameters into this, substitute it, and calculate the surface roughness, thrust force, or whatever they want. So this is how the modeling usually happens. Okay, then I have to check the effectiveness of the model. So this is the model. Okay, so but my experimental results are this. I have to study the effectiveness of this model. For that, what I do is I go with model effectiveness. So whenever R square is the primary term that we use to compare my experimental result with that of the what is it, my model result. This is not fuzzy. Let us have this as a regression result. Okay, so this experimental result and regression result, to compare it, we use a parameter called R square. So whenever the R square value is greater than 80, whenever the R square value is greater than 80, it indicates, whenever the R square value is greater than 80, it indicates that there's a good correlation between my model value and the experimental value, which means I am creating a deterministic framework for this particular combination. So this is how we do modeling. Okay, so this is an industrial case study of data analysis. So this is one thing that we could do when you design our experiments. This is what many people work on. Where many area people work. So all of us use these kind of tools. Okay, industrial case study is something where like we collect the data from the industry. Okay, and then we build the frameworks. Okay. Um, I have only 15 minutes time, so like I will go to Google Colab right away. Okay, but just giving a brief overview here. So when you do Six Sigma data analysis, there are a lot of data analysis we do in industry. Okay, we could get their data, build interpretations. Okay, here by means of using these tools, lot of interpretations can be done. Lot of interpretations can be done. Okay, here I am trying to by gauge R&R is one technique in an industry we use in order to assure that the data generated is right. For that, like all the people, for instance, there is an examination happening, there are 10 different 15 20 people are correcting the paper. Okay, whether all of them are correcting it correctly or not can be analyzed by means of using Minitab software. So that technique is called as measurement system analysis. This has been widely used in industries to see the performance of the operators. So in a mechanical industry framework, in order to do the data collection, okay, with the help of domain knowledge. So domain knowledge is also very critical. Only by means of doing the tools of data analysis, we cannot do anything. Domain knowledge is very important. Okay, so this is one thing we did in the industry where we established a framework. And we established a framework for data collection. Okay, we collected huge amount of data. Okay, I'm just showing a portion of it. Okay, this with the help of this we come with control charts. Okay, to see how the pattern. Okay, the pattern behavior. Okay, and this control charts will be help me to identify the outliers and eliminate it by further data analysis. Then we do something called normality test. Okay, normality test is nothing but I have to check whether my data fixed to a certain distribution or not. So I just do the test whether this test is called as Anderson-Darling test or Anderson-Darling test or normality test. We do this test. Okay, and then we go for the distribution. Okay, so though the distribution says like it is almost a normal distribution curve, AD test fails, Anderson-Darling test fails for us. Okay, if you look at the p-value, okay, so with respect to the p-value, it indicates like we are rejecting the null hypothesis. Okay, so we are not going to use this data. So then we do for process capability studies. Okay, for that also we use a data analysis software called Minitab, and we estimate CP/CPK. Okay, and from the data analysis we are able to understand that these two are the areas where we need to improve. Okay, whenever the CP and CPK value is greater than 1.3, my process is good. The other area is where we need to uh, in CKC, see, this requires a lot of domain knowledge. Okay, I'm just indicating, I'm going in directions how data is throwing me. Okay, but I need to apply my domain knowledge and see whether I'm going in right direction as well. Okay, and then I'm going to collect data only for these things, and I'm going to assess it. Here it falls under a normality probability. So probably what we do is we look into these parameters, we look into these two parameters, and see like what are the corrections to be done. We do the corrections, and then we collect the data set. Again, we assess the Anderson-Darling test, and we generate the distribution plot. Okay, so here it falls well within the normal distribution plot, indicating that data is good. Okay, then we go for control chart. So here we're doing a comparison. This is the after implementation, the changes in the system. This is before. So how the control chart has improved. Generally what happens is the standard deviation will be reduced. Okay, and then you could see the normal probability plot. Okay, see, this is what happens before. Okay, when the data doesn't fall normal distribution, it is how like this. After normal after bringing a change in the system, okay, the data falls into the normal probability sector. Okay, where you could see it is very in a linear condition. Okay, this is giving me more. So now it is started, it passed the AD test. Okay, so we could also estimate the CP/CPK value. Okay, so here you see I'm using bar graph to compare the CP/CPK value. You could see like I could show a clear indication in my CP/CPK value. So I have been quite fast here, I know that, but since time is running out, I'm just going a bit fast. And then we have the how to build a model. Generally you have to create a database. So in order to build a model, you have to create a database. Creating a database is the first step. For generally in engineering conditions, like when you do experiments, this particular frameworks will be very usual, what I said you earlier. Okay, and tools like Minitab and Excel would come in handy. But today what we are going to do, especially like when you do vibration, you have to do a fault detection using vibration analysis, or when you are going to do a process monitoring using sensory outputs. Okay, the volume of data that is required to build the model is going to be huge. I'm going to continuously collect data. So that is where I build, choose it. I get my database. I read the data, visualize the data, pre-process the data. Now, in order to build the regression model, I cannot do it directly there. To build the regression model, I have to split the data. So generally, what I do is, we do generally call train data and test data. Okay, so we split it into two and build a model, train it, and the test data is used to evaluate the effectiveness of the model, and then the model valuation. Okay, after doing the model valuation, we try to implement the model. Okay, so this is what we are going to do for next few minutes. Okay, so I will try to go to Google Colab. Minitab is a very handy tool you could use for this kind of assessment. Okay, but my suggestion is whenever I said, like when you're going for fault diagnosis, when you're going for huge volume data set, sensory outputs. Okay, that will not be sufficient for us because you will be handling a huge data set. Okay. Sorry. So we are using something called Google Colab. Okay, so this is an open source tool. Okay, you just go to the Google and click Google Colab. Okay, you just go to Google. I have tried Google Colab. Okay, when you click on Google Colab, this will open. Okay, you go to File, click on New Notebook. This will open. Okay, so this is the new workspace. Okay, so generally when you have continuous data today, many areas we use this kind of uh, processing tools. This is open source, so Minitab is something like we require a license. Here you no need to use any license. This can be used for regression analysis, this can be used for ANOVA analysis. Yeah, we can use like if you like regression, etc., varieties of regression. Okay, today people when they use advanced regression techniques, they started calling it as machine learning. Okay, we are using regression techniques for quite a long period of time, especially the field of mechanics, but they call it as machine learning. So you can say like you're also working on machine learning. Okay, only thing, the data set volume will be very huge. So like for creating data set for these kind of things, you could put sensors into 10 15. For instance, vibration, from 5 different points you collect the vibration signals. Okay, to compare and build regression model using vibration signals and build inference, we could use feature extraction and classification of vibration signatures. We can use this thermal signatures. We can use this. Okay, so this is very very important. But only thing that we need to use from your sensor, you need to build in a database. That is very important. Okay, in our case, I'm going to use common database. So this is a database that is available. And there is a platform called Kaggle. Okay, the Kaggle platform, they conduct a lot of competitions for you to perform a lot of data analysis things. So this data set is actually obtained from Kaggle for just demonstration purpose. I have taken Kaggle. Okay, so here if you look at this, you have different variables. Variable 1, 2, 3, 4, 5. So when you talk about variable, these are factors. We have almost uh, we have almost 10 factors here. Okay, and then if you look at the what is the levels of values that we have. Okay, so it's so huge. So this is what sensor is actually creating to us. Okay, it collects large value of information throws to it. Okay, so which means going forward we need to do analysis with complex tools. So look at the data set. Okay, so this kind of data set can be used into using softwares like Google Colab. There are a lot of packages available today. Your use of these tools also become very simple because there are a lot of packages available. Okay, so I have opened Google Colab, so I hope many are following with it, and you can also try along with me to follow it up. Okay, I think they're recording it as well, so that the recording option is also available for you. You could go back and try running this code. Okay, this will help you to give a good if you practice this particular scenario, this will help you to get a good understanding of using this particular platform. Okay, so first I go to this folder, click on this folder. Okay, So this is the place where I am going to load my data set. Okay, so what I'm going to do is I'm going to pick the data set. I'm going to pick this data set housing. I'm bringing it here and I'm going to drop it here. Okay, so it says like only when the session is alive, it will consider this data set. Okay, so once you close the session, okay, this data set will not be available. So we'll have to again use the data set. Okay, so that is what it says. Okay, it is loading for us. So you could see housing CV is CSV is available. Okay, so the Excel sheet that I showed you is now loaded into my notebook. Okay, now I'm going to do a lot of operations. Okay, so the quicker operations, I have the code already available with me. So what I'm doing is here I am importing the data set. Yeah, there is something called code plus. Click on the code plus. Very similar to using Python. Click on the code plus. Control V. Okay, you put the code here. What I'm doing is I'm using something called df. Okay, and storing this particular data housing.csv. Now I am playing it. You see, I get a tick mark indicates like the data is loaded. So I'm setting a variable and I've loaded this value housing.csv into this variable df. Okay. Next, what I'm going to do is I'm going to check whether the data set has been loaded into my data folder. So click on code, enter. You could see. Okay. So when I put df it shows me only it's a huge volume of data. It shows me the few values of data has been shown to me. Okay. Now I'll try to see more amount of data. I am going to see 10 values. You can see almost all the 10 values are available here. Okay, so this is how we check whether the data is loaded. So first what I do is I load the data into my file that I'm working on. I define a value for it. I define df. So whenever I'm going to, I have given a variable name for my data set df. Okay, whenever I'm going to use this particular data, I'm going to use df. Okay, so now I used the head command. I'm able to display the data set. In this particular parenthesis, if inside you put the number of 10, 15, 200, 13, you put those number of values will be displayed. Okay. Next, I go for df tail. Tail is nothing but the last data set is something it will show me. So I go to code test. I play the backend. Okay, the last 5, 6 values it is showing me. Okay. Now I use df tail 4. Okay, the last 4 values will be shown to me. So the last 4 values are available here. Okay, you could see this, right? So this is how you read the data is inside it. Okay, do all those things that will help you to come very like familiar with the tool. Once you are familiar with the tool, lot of things you could try and see, because no money is involved here, right? So you could play the things. I am going to retrieve a data. Okay, so what I'm doing is I'm putting this one row of data. Okay, so for one row of data is something alone I have retrieved. Okay, so you could take any. So I have loaded all the entire data set here, so you could retrieve and see. This will be very useful when you are using thresholding functions. Okay, right? We might have to build in some retrieve some amount of data set. Okay, now let's do a data visualization. Okay, I said like distribution is very important, so I go for a histogram development. Okay, so this is the code that is required. So I'm using the code, playing it. You see, that means I'm using Google Colab. I've created distribution. Okay, so all distributions can be generated. Okay, now next one I'm going to jar a scatter plot. Okay, when I'm going to use a scatter plot, I'm using a package. Okay, matplotlib is a package available, a Python package available. I'm using that package, so I'm importing that and then I'm using it. So I go to code plus, importing that. See, I have come up with the scatter plot. Okay, I mean the values I gave random values, so the scatter plot doesn't show much of a significance. But this is how you have to create scatter plots here. Okay, I mean you can go for creating bar graph. So for all those things, code is actually available. Okay, just click on code plus, put the code with respect to the your defined functions. Very easily you will be in a position to operate with the tool. It's just you need patience in getting yourself associated with the tool. Okay, so when you are using some particular functions might request you to import the particular package. So I have used matplotlib package is something I've loaded and then I've executed the particular application. Okay, now what I'm going to do is now this is something called pre-processing of data. Now my data, it might have some categorical values. This categorical values has to be coded with 1 and 2. Okay, coded with some numerical values. For that we use a platform called lab encoder. So when what it does is it completely looks for the uh, categorical values and codes it into 1 or 2. Okay, for that we use this particular code. My PPT has got all the codes and explanations along with it. Okay, so when you see that, you'll understand better. Okay, so here ocean proximity is having categorical data. Okay, what I'm doing is I'm using a lab encoder application, and this ocean proximity has got categorical values. This categorical values will be coded with a numerical value, so that that can be brought into my modeling. Okay, so if you retrieve the data set and see, it will have this ocean proximity will not go longer will have categorical values. It will be converted to numerical values based on the function that we have used. Now I am going to look for missing values in my data set. So here I'm almost handling a number of rows, almost like 30,000 rows value I'll be handling here. Okay, so I need to understand whether all the values are fully available. There might be some values missing. For that I use this code. Okay, if you look at this, all the columns, okay, all the columns, longitude, latitude, all of them has got all the values. So not no, everything has got values. Now total bedroom is having a problem. Okay, total bedroom is is a column that is not having all the values. So for that, what we use is what we need to use is we need to fix this. So I need to know, like, in total bedrooms, how many empty cells are there. Okay, how many values are missing. Okay. I use this particular command. Now 207 values are missing. Okay, so now when I go and build a model with this, my model will not be accurate. So for that, what I'm going to do is I'm going to fill the missing values. Okay, in order to fill the missing values, I'm going to use this particular function. Okay, where what I'm going to do is I'm going to fill the missing values by means of using mean. Okay, I'm going to take mean value of total bedroom, and wherever the total bedroom value is missing, okay, I'm going to use mean value. See, whenever when you create 20,000 or 30,000 data sets, the values missing is quite common. Okay, so you could use mean, median, mode to fill the values, or you could also use hot values like zero, to fill the values, or it can be some fixed values that you could use. Only then you will be in a position to model it effectively. Okay, so I am, if you look at it now, those values, okay, are filled with mean. Now we'll have to again check. For that, what I'm going to do is I'm going to again run the code to see for empty cells. Everything, what should I get? I should get everything false. Everything is false. Look at total bedrooms. Everything is false. Okay, so we have done this correctly. Okay, so we have completely finished. We can also try it the other way. I can again run this. You can see, like, total bedrooms earlier it was 207. Now the 207 column gaps are being filled with values. Okay, so that is how we are processing it. Now in order to build the model, what I said earlier was we will split the data. So I have 20,000 rows of data. I am splitting into two. So 80% of data I am taking it in one area, that is called training data set, and 20% I'm taking it as test data set. Okay, so that is what I am going to do now by means of using the Okay, before doing this, what I'm going to do is now I have got all the response onto my data set. Okay, I'm going to drop off median income. Okay, now there is, I'm going to split the table into Y and X. Y will have only medium income value. X will have all the values except medium income. Okay, because what I'm going to do is median income is nothing, was going to be my response. That is what I'm going to measure. I'm putting that as a function of X. Okay, I am putting that or associating that as a function of X. Okay, I am running it. Now I'm splitting the data table. Okay, now if I put simply X and play, you see, you will not be able to see median income in the heading. I have removed this. See, look at this. We have almost 20,640 rows. It is no longer 9 columns. It is only 10 columns. Now I want to see only Y. I have only Y here. Okay, only median income I have here. Now this Y and this X, I am going to combine these two and create a model. So I'm going to create a model Y is equal to a function of this. So this is how I'm going to create an equation. Okay, that is what I'm going to use it. Okay, so now I'm going to split the data set into 80 and 20. So I split the data set into 80 and 20. So what I'm doing is I'm generating 4 data set, X train, X test, Y train, and Y test, and I'm splitting them. Okay, into training, I'm taking it as 0.8. Okay, so that is how I'm splitting it. A random state is generally given in order to bring in a degree of randomness in my splittingness. Okay, so that random state 8 is given. Okay, now here also I have used one Python model. Okay, so sklearn is a package available. I load the package and then split the data set into 2 groups. Okay, just give me another 5 minutes time. I'll just wrap it off. I know it's lunch, but like this will be useful for you. Okay, so I'll just finish it off quickly. Now I'm going to build the model. Okay, so I am building a regression model here. Okay, I'm building a regression model here. Okay, so I'm going to run this. So when I build the model, so the linear regression model is ready for us. This regression model is built based on the training data set. Okay, there's also another type of regression. Okay, that is called SDG, steepest SDG. Okay, like it is called as steep gradient. Okay, regressor. Okay, so that type of regression technique is also we can build it. There are different types of regressions: probabilistic regression, logistic regression, different things. We can also build that regression as well. Okay, so I'm using steepest gradient regressor here, building that model as well. So I have built 2 models now. See, I have built 2 models. Like this, you could build many models and study like which model is more effective for your data. Okay, now the models, these 2 models are actually built using the training data set. Now I'm going to use test data set. Okay, so I'm going to see the effectiveness of the model for the test data set. Okay, so what I'm using is I'm using Y predict 1, Y predict 2. Okay, and I'm estimating the values. Okay, so X test data I'm using and estimating the values. Okay, I'm storing it into Y predict 1 and Y predict 2. Okay, and then I am running my model. Okay, and then I have finished running my model. Okay, so this is how we have to develop models. So this is very, very important for us, in the field of like manufacturing, especially like this kind of models are very, very crucial for our success. Okay, with industry 4.0 coming in. Okay, so with a lot of sensors being put into these systems, almost all the informations can be collected, can be used to build models for prognostics and all those things. Now I have built the model. Okay, now my prediction value is also available. Now I have to study the effectiveness. So as I said earlier to you, R square is what I'll be using it. We can also use mean square error. There are also other parameters that can be used for evaluating the model. Okay, I am just loading, from sklearn metrics, R2 square and mean square error alone. So I have print only R square value. I didn't consider mean square for now. Okay, if you want, you can print that as well. Okay, you could see like I am getting a 65% of correlation. Okay, so my predicted value. Okay, and my test value, both of them, okay, with the test value and the trained value, my model effectiveness is 65 percentage. My model effectiveness is 65 percentage. Okay, so this is my model effectiveness. So now I need to improvise my model. Okay, or I could say like the current model doesn't fit in. Okay, so this is how I evaluate the model. I can also do for SGD. Okay, the same will get. So now I'll have to see what is the problem, why there is a drop in my model, whether now all these X might not be and having an impact on Y. Okay, for that we could do ANOVA analysis and study and remove some of the X which is not having an influence on the median income. Okay, and then proceed further. Okay, so this is how we could perform modeling by means of using Google Colab software. It is a very famous software. Okay, so when we use this software, we could say like we are using ML. We are actually working in ML domain. Okay, with the help of this Google Colab, we could actually create lot of and with the help of this Google Colab, you could create lot of models, lot of assessments. And today, means that we use Arduino and those kind of circuitries. We could use sensors, use Arduino, collect data into an Excel sheet, and perform lot of analysis. Once you get the analysis, okay, you could throw it into the open source software and try all the models and see. And we can focus on developing one good model for your research work. So with this, I'm winding up my talk. So the presentation contains step by step like how to use this code. Okay, I will also share the word file of these codes to Murugan sir so that he will share with you. I think the video is also being recorded and it will be given to you. You could see the video and then practice it when you have time. Okay, so this is polynomial model. So when you use polynomial model, you could go for different types of regression. So now I'm closing the session. In case you have any queries, you could always reach out to me. Okay, my mail ID is vimalsamsinghr@sn.edu.in. In case of any queries or you would like to work more in this kind of areas, you could always associate with me. Thank you. Thank you to all. Thank you, sir.
Thank you, Professor.
Thank you, sir.
Dear participants, if you have any questions, you can either post it in the chat box or you can unmute yourself and ask Professor Vimal.
So I think we are given very limited time to you, Professor. Actually, the topic is very vast.
Yes, sir. Maybe like this is can be an opening session for them, sir. And if they are interested, then you could try hosting one more session later, sir.
Yes.
Sir, there was a question in the chat box.
Yes.
It was about what are all the tools that we can use for artificial intelligence and machine learning for WSN.
Wireless
Sensing
sensor
network.
networks. Okay.
Yes, sir. Yes, sir.
So wireless sensing networks like Google Colab, which I showed, right? So we also work, myself and almost do work in wireless sensing networks. Okay. So there we could use the tool that I demonstrated, right? Google Colab. That is something you could use. When you use those kind of tools, it falls under machine learning category. Okay. I showed you the models like linear regression model and SDG model. Okay, you could also work on like there are various other models available. Okay, and if you look at AI models, Python is very wonderful tool. There is a package called SKI fuzzy. Okay, that is the package that you could load and build try building AI models. Okay, so for wireless WSN you could use Python tool framework, and then you could use fuzzy logic and neural network to develop models.
Thank you, sir. I have a personal question, sir. Like how important is programming for mechanical engineers nowadays? So because there are a lot of mechanical engineers who are being recruited in software companies. So how it is important in the current scenario, sir?
See, programming is very crucial, not only for mechanical engineers, for anybody today, okay, even for a management person. The demand in the market nowadays is he needs to know some amount of programming. And like many say, like mechanical engineers, like not done much of programming. It's not the case. Our curriculum by default has got a lot of we use, like Fanuc coding. Because that's where we start our learning about programs. Today, if you look at areas like many other areas where we use a lot of when you work on mechatronics, okay, subjects like mechatronics, then they work on PLC, hydraulics and pneumatics. Okay, when they work on hydraulics and pneumatics, okay, they start working, on ladder logic diagrams. So I don't see it is something very new to the field of mechanical. Even if you look at the regression techniques, right? It is when you look at mechanical production department, okay, people who are very good in process planning and cost estimation, they use lot of these kind of tools. Only thing in an industry, only thing what happened is like now there is a new field coming up called econometrics. They use the same concepts that has been used in production engineering now, and they say like it's a different. I don't say mechanical engineering is not very new to coding. We are actually been doing it for a long period of time. Only thing is nowadays the name has changed. Okay, they data analytics or data analysis is been part of our curriculum for longer period of time. When we do Six Sigma, we have been using a lot of tools for this already in the earlier case. Only thing is now it has evolved into a separate branch. So what by addressing, I think what I'm trying to say here is it is not very new to us. It is very very commonly we have been doing. Only thing now new tools are coming in, so just we'll have to adapt to it. Only thing, because our curriculum or our way we have been trained, it will be very easy for us to learn programming. It is not very difficult to learn programming, as we are involved in many logical aspects already in our machining and various other areas. So it is very important. If you ask me, programming is important. Programming is important for everybody, and for mechanical domain we always learn program. It is not something very new, and it is only in our field there are a lot of new evolution is happening. When you talk about industry 4.0, it's actually associated with the field of mechanical engineering. So it's not new to us. That is what I would try to say, and it's very easy for us to learn as well. And at this point of time, it is become an inherent tool. Today, whichever area I keep my hand, in order to operate it, I need programming. Otherwise, I'm not able to operate. Soon we'll have machines where I will run only with codes. So that is how the system is going to happen. So it is very important for us to stop saying like program is no, it is it's not no longer a taboo for mechanical engineers. Learning programming is not a taboo. It is what we are going to do in our upcoming days. Hope this answers your question. Amos.
Thank you, sir. Morgan, sir. So we have come, sir, can we wind up, sir? Yes, sir. So we have come to the end of day 2, session 2, which was handled by Dr. R.Vimal SamSingh, Associate Professor, SSN College of Engineering, on the topic tools for the modeling and optimizing the research data. Thank you, sir, for joining us.
Thank you, Amos, and thank you, Murugan, sir, for giving me this opportunity.
Thank you very much, Professor. Thank you.
Thank you, sir. Thank you, sir.